Okay, so for problem number one here, we've got three parts to it. On the quiz though, it's just going to be the one question. There won't be like A, B, and C on the quiz, okay? So here we have a coin that's flipped. And when we do probability, you see lots of questions about coins and cards and dice, okay? But when you flip a coin, you know that there's just two options. There's heads or tails, okay? So if it's flipped 8 times, because you guys have got a lot of free time now, so you could sit there and you could do this. You could flip a coin 8 times. Hear it? It's like, no, I don't want to do that. Okay. But we want this order to come up. We want tails, heads, heads, tails, 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 tails. Okay, so for whatever reason, we want that order. But really, there's just two options every time that you flip a coin. So you could get heads or tails, heads or tails, heads or tails. Okay, so really, even though we've got 8 options here, 8 times that we flipped it, and we want certain outcomes, there's still just going to be 2 options every single time we flip the coin, and we're going to do that 8 times. So that's really 2 to the 8th. Okay, so this will give us our total number, which is 256. So there's 256 different combinations that we could get when we flip a coin 8 times. Okay, and then this order here in the problem, that is one specific order that they want. There's only one way to get that to happen. So our probability is going to be that one option out of the 256 total ways that you could flip a coin 8 times. Okay. So you don't have to think of calculating getting tails for the first one or getting heads for the second. You don't have to get that specific about it. It's just one option out of the total. Okay. Now, if you want tails to come up exactly twice, when we're dealing with probability and statistics, we got to watch out for our language. So it's bolded and italicized here, this exactly. Okay, that means we want only 2 heads. So when we flip the coin 8 times, we only want heads to come up twice. Okay, so that means out of all 8, we only want 2. So we're going to use our combination notation here, and we're going to do 8, choose 2. So of all the 8 flips, 2 of them will be heads, or tails, sorry. Okay, so that's what we want out of our total, and our total is the same as what was up above. That would be the 2 to the 8th, or the 256. Okay, so remember, for probability, it's basically what you want out of the total. Hopefully remember that from basic probability stuff that you've seen in algebra, geometry, and algebra 2. Okay, this combination we can do in your calculator. I think we talked about that before in chapter 12. At the end of chapter 12, there's stuff with the binomial probability that we can do. So remember, that's in the math menu. And then you want to go to prob. And then it's option 3 for the combination. Okay. There's also a permutation. I think that's option 2. Okay. So it'll say NCR in your calculator. So that's what you're looking for. And then it'll give you little boxes. You can type it in for the N and the R. Okay. So then when we do that, what do we get? When we read, we get 28 out of 256. And then you always want to make sure you reduce it down. The directions on the quiz will tell you to reduce it to a fraction in simplest form, or it'll say make it a decimal, and we'll tell you how many places to round to. Okay, so then when you can reduce that in your calculator might even reduce it automatically for you. Okay, 7 out of 64. Okay, so that's a pretty small probability. If we divided those and got the decimal for it and made that a percentage, that would be a really low percentage. Okay, and then for number 1, part C here, again, this is more vocabulary. Okay, this says at least. So we want tails to come up at least twice. Okay, so that's different than exactly twice. Okay, at least twice means it could be 2 or 3 or 4 or 5 or 6 or 7 or 8. okay? So we've got 6 different options basically for what could happen. So you could do what we did for part B, do 8 choose 2, and then you'd have to do 8 choose 3 and 8 choose 4 and 8 choose 5 and so on all the way up until 8, and then add them all together. Or we can use a little shortcut. So we know that our total is going to be like 256 out of 256, which is 1. That's our total. And if I want 2, 3, 4, 5, 6, 7, and 8 tails, that means I don't want 1 or 0. So those are my 2 options that I don't want. So I'm going to subtract off those. So I'm going to subtract off the 8 choose 0 out of the 256. And then I'm going to subtract off the 8 choose 1. So this is just a little bit of a shortcut, so you have to do less calculating to get your answer, okay? So that's going to be 1 minus 1 out of 256, because there's only one way to get none of them, and then 8 out of 256. There's 8 ways to choose 1 that comes up tails. And then that'll get you 247 out of the 256. Okay, so much better probability of having that happen. Okay, so the main takeaway on that one is just to remember that shortcut. Okay, and watch out for the vocabulary. How do we feel on that stuff so far? Okay, all right. Let's see, let's go on to number 2. Here again, we've got a jar with different colored balls in it, because I know you all have these, right? Sitting at home. Yes, okay. Maybe let's pretend it's like candy. It's M&Ms, it's peanut M&Ms, okay? So we've got 10 that are green and 9 that are red. So we're gonna find each of these probabilities then, okay? So again, we have to know our total. We've got 19 total, so we have to remember that. And we wanna have all of the 5 that we're choosing be red for our first outcome here, okay? So again, this is what we want out of our total when we're finding our probability here, what we want out of the total. So we want all of them to be red. So I want to choose from the red ones. So those 5 that I'm picking, I want them to all come from the 9 that are red. So we're going to do 9 choose 5. Okay. And there's really 19 in this jar. So of all of the 19, I'm just going to choose 5. So that's how I get my total. And sometimes students get confused on that. They want to do the 19 choose 5 as what they want, okay? But we only want red, so I don't want to count the green ones at all. And then again, you can do that in your calculator, and your calculator, where'd my mouse go? Will get you, there it is, mousy. If you do one at a time, 126 over 11,628. Oh my gosh. And then when we reduce that, 7 out of 646. So again, if we actually divided that and got a percent, it would be very small chance of that happening. Okay. And then if we want 3 of the balls to be red, this is going to make it a little more challenging, but we're still going to use our combinations. Okay. Remember, you use combinations when order doesn't matter. So it doesn't matter what order I pick 3 of the balls to be red. It could be the first one, it could be the last one. The order doesn't matter, okay? When order does matter, that's when we use a permutation. So that'll be coming up in a little bit too. Okay, but now I want 3 of the balls to be red. So of the 9 that are red, I want to choose 3 of them. But I've got to pick 5 altogether. So that means the other 2 have to be green. So from the 10 that are green, I want to choose 2. And then we'll have our total on the bottom. So that's the same as what we did before, the 19, all of them, and we're choosing 5 of those 19. Okay. And then again, put that into your calculator. You can get each number separately. Let's see, the first one should get you 84, and then 45, and then we'll have our total. The total should be the same as what it was above, 11,628, and then you can multiply and reduce. The answers are on the second sheet there, but I'll write them down. 323. Okay, so a little bit better chance of that happening. Okay, about a 33% chance. So I would make sure we understand the concept there for B, okay, because that's a little bit more complicated than A. So be sure you're comfortable with that. Look that over in the video notes again. Maybe do some homework problems like that if you need to practice it a little bit, okay? Just think of, we want 3 that are red, so we're choosing those from the 9, and then we still need 2 to be yellow to get our total of 5, okay? Okay. Number 3, this is a pretty basic one. This is a permutation though, so that's the difference between number 2 and number 3. Permutations are when order matters. So we want to make 6-letter words from the letters in digits, okay? And there's kind of an issue here because we have 2 I's in digit. So it's when order matters, it depends if you are picking the first I or the second I. But since they're the same letter, we don't know which is the first one and which is the second one, okay? So order matters here when we're making words. I know they won't be actual words if we rearrange the letters, okay? But this is going to be a permutation. And permutation in your calculator, if you go to the probability menu, it does look like NPR, but also there's an N factorial. There's an exclamation point in the probability menu too. And that is when you have a number that you want to start with, and then you want to multiply it by every other number that's less than it. That's also a permutation, okay? So here, that's what we're doing. If we're picking a 6-letter word, we've got 6 options for the first letter, and then we've got 5 for the second, and then 4, and then 3 options, and then 2, and then 1 option left for the last letter, okay? And that is 6 factorial, okay? So that's only 6 times 5 times 4 times 3 times 2 times 1. That's easy enough to just type in. But if it's a really big number like 24 factorial, then use the exclamation point in the probability menu, okay? And then since 2 of those letters are the same, we don't want to count them twice. So we'd have 2 options for the first I and then 1 option for the second I. So then we've got to divide by 2 factorial, okay? And that's not like 6 divided by 2 is 3. We can't think of it like that. But what it's going to do, it's going to chop off the 2 times 1 on the end there, okay? So then when you calculate that, you'll get 360. So there's 360 different ways that we could arrange the letters, digit, okay? So dividing by that 2 factorial, that just makes sure that we're not counting the arrangement of the I's twice, okay? All right, let's see, I think the rest of these are all combination problems, okay? But just know that we can use permutations when order matters, okay? So number 4, this is a good one where we're forming a committee here, and you've got specific ways that you need this committee to be formed. So we've got 6 people that we want on this committee. We're choosing from 7 men and 8 women, so we've got 15 total that we're choosing from, okay? So again, this is gonna be, you know, kind of a what we want out of the total situation is what we were thinking before. But here it says, how many ways can this be done if at least 4 women must be on the committee, okay? So again, there's very specific terminology here when it says at least and it's bolded and it's italicized. So that's going to change how we count. Okay. So that means if we've got 6 people that we're trying to fill on this committee, we want 4 of them to be women, at least 4. So it could be 4, or it could be 5, or it could be all 6, could be women. So those are the 3 things that we have to count and then add up, okay? And order doesn't matter. It doesn't say anything about how the first woman has to be tall and then the second woman has to be short. They're not being really specific on that, okay? So order doesn't matter here. So it's gonna be a combination. They just want a group of 4 women. So if we have a group of just 4 women, let's see, from the 8 that are women, we would choose 4 of them, but we need 6 altogether on our committee. So then from the 7 that are men, we would need 2 more, so we could get that total of 6. Okay. And then if we want to choose 5 women to be on the committee, we would have 8 choose 5, but then we would need 1 more man, so 7 choose 1. And then if there were all women on the committee, it'd be 8 choose 6, because we'd be choosing from those 8 women. And then from the men, we wouldn't choose any. So you do have to put that in there, but 7 choose 0. There's only one way to choose 0 of men. So anytime you have something choose 0, that's just going to end up equaling 1. Okay. So if you didn't write that in, it wouldn't be the end of the world. Okay. So then we just calculate those out and then we add them all up and we'll get our total for that one. So we should get 1470 for the first one here, and then 392 ways for the committee of 5, and then 28 ways to have a committee of all women. And then if we add those all up, we'll get 1,890 different ways that we could do that. Okay. That's why it's so hard to pick a committee, because you got to figure out all the different ways that you can have it formed. How's that? Good? Okay. Now the problem where we did that little shortcut, or was it number 1C, where we kind of take our total and then we subtract off what we don't want, you could have a situation where we combine that concept with what we did for number 4 as well, okay? So let's say the problem was a little different, and it said we need the committee to have at least 2 women, then we could have 2 or 3 or 4 or 5 or 6. So that's 5 different things we'd have to calculate and add up. Whereas we could use the little shortcut where we do 1 minus, and then the ways where there's only 1 woman, and then the ways where there's only 0 women, there's all men, okay? So you can use those 2 concepts together from number 1C and number 4. We can kind of use those together if we need to, okay? So maybe put a little star by number 4, make sure you're comfortable with that, okay? For number 5, they're talking about cards. Are you guys familiar with cards? Some yes and some no. Okay. So when I first started teaching, kids knew cards because they play cards with their grandmas and grandpas and stuff like that all the time. But lately, it's like students don't know cards as much. So download some kind of card app on your phone, like Solitaire or Free Cell or something like that, okay? And if you have questions on the cards, you can email me or you can Google it. You can look it up on Google too. Google will tell you all the information you need to know about cards. But there's 52 total in a deck of cards. There's 52 all together. And there's 4 kinds. Uh-oh, what's that say, Garrett? I can't see it. Unmute it. Unmute yourself and tell me what it is.
4 suits, 12 face cards.
There you go. Yep. So there's 4 suits. The suits are the different types of symbols that are on there. So there's hearts, and then there's diamonds. That's a really bad diamond. There's clubs, bloop, bloop, bloop. Looks like a little flower. And then there's spades. They look like a little pointy thing. Oh gosh, that's awful. Wow. Okay. So those are the 4 suits. And then 2 of them are red and 2 of them are black. So you have red and black colors. And then if you take 52 and divide it by 4, you get 13. So there's 13 cards in each suit. 13 cards per suit. I guess I'll write it like that. Okay. So that's just some basic background information. There's face cards as well. So here when they're talking about the face cards, those are because they have pictures of kings and queens and jacks on them. So the face cards are the kings and the queens and the jacks. And then the other cards are 10 through 2, if you count down. And then there's also an ace. And sometimes the ace is considered a 1. Sometimes the ace is considered higher than a king. So they'll tell you how to count the ace, if it's counting as a 1 or if it's counting as higher than a king. Okay. But here we're playing poker. I don't play a lot of poker. I don't have a good knowledge base of that, but you don't need to. We're just counting, okay? So we want a card, a 5-card hand, to have all face cards. So it's got to be kings, queens, and jacks. So that's the only thing that's allowed in our hand. And again, this is a situation where we're dealing with what we want out of our total, okay? So we can think of it this way, what we want out of the total. Okay. So there's a king and a queen and a jack. So there's 3 face cards and there's 4 suits. So that means there's 12 face cards altogether. So there's 12 total face cards. That's what Garrett told us. Okay. So we want to pull our 5 cards from those 12. So we're going to do 12, choose 5, because they say nothing about order. It doesn't say a king has to come first and then a queen and then a jack, or a red king has to come and then a black queen. Okay, they're not saying anything real specific, so we don't have to worry about order here. It's just a combination. Okay, and then our total, there's 52 cards total, and we're choosing 5 from those 52. Okay, so there it is. There's our probability. It's what we want out of the total. So we'll have 792 ways that we could get 5 face cards. Yikes. And then the total for how many different 5-card hands you can have, this is a ridiculously large number. 2,598,960. So you'll see that number a lot if you're doing 52, choose 5 for card problems. You see that over and over and over again. Okay. And then you could try to reduce that as a fraction. These probably want to write it as a decimal, 0.0000305. So that's our decimal. And if we made it a percent, it would be a 0.0305% chance. So that's not even 1%. That's not even half of a percent. It's not even 1/10 of a percent. Okay, so that's a very, very small chance that that's going to happen. So if you're playing poker and money's involved, do not take that bet. You're not going to win unless the cards are stacked, and then that's not fair. Okay, so we're assuming that the cards are shuffled. It's a fair hand, a fair chance of getting that combo. Okay, Jared's getting himself some coffee. That's nice. Okay, one last one, and this is with the binomial probability. So this was in section 14.3. Okay, this you'll definitely see on the quiz, this concept of binomial probability, if it's a whole section. Okay, and this is basically just a quick way to count. Okay, when things aren't fair. So I just said how when we shuffle the cards, we want to make sure it's fair. That means you've got the same chance of getting a card every time you draw. But here it's not fair because 60% of the voters favor some school initiative. So that means 40% don't favor it. So it's not fair. It's not 50-50. It's not even. Okay. This would be like if there were weighted dice, okay? Or left-handed or right-handed people, or Cubs fans versus Cardinal fans, okay? So it's not going to be the same across the board. So anytime it's not fair, we're going to use this binomial probability, okay? So here we want exactly 3 people to favor it. And there again, there's that very specific vocabulary, exactly 3 of them, okay? So we've got 5 that are being interviewed. So I'm just gonna make little dashes to help me kind of visualize those 5 people. Okay, 3 of them are going to favor it. And then the other 2 are gonna have to be against it. Okay, so that's just kind of the situation that we're thinking of here. Okay, so it helps to draw a little sketch like that if you need to help you visualize it. Okay, so of the 5 people that we're going to be talking to, we want 3 of them to favor it. So there's 5 choose 3. So that's the first part of the binomial probability. And then since it's not fair, we have to weigh the 60% and weigh the 40%. So the next part then is going to be that 60%. So we'll write it as a decimal. And there are 3 people that are going to favor it. So we're going to take that 60% to the 3rd power. And then we've got to weigh the people that are against it. So that would be the 40%. And we're going to have 2 that would be against it. So that's going to be raised to the 2 to the 2nd power. Okay. So for the binomial probability, you're always going to have that combination of what you want out front, but then you have to put in each of the percentages and then raise them to the power of what you want. Okay. So then 5 choose 3. If we calculate that, we should get 10. And then the 0.6 to the 3rd, that's 0.216. And then the 0.4 squared, that's 0.16. And then if we multiply those all out, we get 0.3456. That's a good decimal, 456. And you can leave your answer as a decimal. On the quiz, we'll tell you what place to round it to. Or if we want it written as a fraction, we'll tell you that. Or if we want it written as a percent. So we could change this to a percent too. We could say that it's about 34.56%. That's a little more user friendly. But here we can just leave it as a decimal. That's totally fine. And then we're just going to do that again for part B. But since it says at most 2, that means we've got a different way to think of this. Okay, when you're dealing with an exact situation, you just count that one option. But here it says, what's the probability that at most 2 will favor it? So that means if it's at most 2, we could have 2 people favor it. Or we could just have 1 person favor it. Or we could have nobody. We could have none. So we've got to count all 3 of those. Okay. So if we have 2 people favoring this, where'd my mouse go? I keep using my mouse. There we go. We'll have the 5 choose 2. And then to favor it, that's 60%. So we want 2 of those. So we're going to raise it to the 2nd power. And then the people that are against it, that's 40%. And then 2 plus 3 gets us the 5. Okay. So we type that in and calculate that all out. Get a really small decimal, 0.2304. And then we have to repeat this process for 1 and for none. So 5 choose 1. And then the 60% that we want, that's to the 1st power. 40% that we don't want, that's going to be to the 4th power, because 1 plus 4 gets us the 5. And then you calculate that all out, add them up. We're going to get 0.0768, smaller. And then if no people are favoring it, 5 choose 0. And we'll have 60% to the 0 power. So that's going to be 1. Anything to a power of 0 is 1. And then 40% will be to the 5th power, because we want all of them to be against it. And then when we multiply that all out, we'll get 0.01024. And then we have to add those up. And then you can see the total at the bottom there in the answers. Okay, but just know that we'd have to add those. I'll put a little plus there. We should get about 0.31744. And then depending on how you round your answers, your answer could be a little bit different than what's on the answer key, okay? So for these, the more decimal places, the better. I say go to at least 4 decimal places if you're rounding, okay? So that way you're more accurate. And then again, we could make this a percent. It would be about 31.7% if we wanted to write our answer that way too, okay? But the quiz will tell you. So just watch out for that vocabulary, okay? That vocabulary helps you think of the situation and how you're counting it. But that's the tricky part, to figure out how to count it, okay? Because we don't get much exposure with this sort of counting concept, okay? Okay. So how do you guys feel about that? Okay, thumbs up, thumbs up. All right. Okay, Jared's caffeinated. I don't know where his dog went. Oh, okay. Still sleeping by you. Very nice. Glad the dog's enthusiastic about pre-calculus. Okay. So the quiz will be on Canvas at 11 o'clock. Okay. You guys can form a little Zoom study group if you want. Okay, work on it together. You'll have unlimited attempts just like before, okay? And remember, that's a good advantage that we don't have. If we were in class and doing this paper and pencil, you wouldn't be able to just retake it and retake it and retake it, okay? There were no retakes in class, so now you have retakes, okay? So take advantage of that. Make sure you try and get 100%, okay? Quiz will be 5 questions, 2 points each, so it'll be 10 points, just like it was before. But it goes in the quiz category, so then that means it can raise your grade 1 to 2 percentage points, okay? Okay. Even the old quizzes or the tests from like chapter 12, if you still didn't get a perfect score on those, go back and do those. Keep working on them, okay? I know Jared had emailed me some questions on the, was it the test, the chapter 12 test? I think it was, okay? So go back and try and get a perfect score on those, so that way you can raise your grade, because you can move up a whole letter grade. You know, if you were at like a 84% or something like that with each of these quizzes and tests, you could be in the A range by the time we're done with the year, okay? Okay, so we've got this quiz, we've got one more quiz, and then we'll have the chapter 14 test, okay? I think next week is just like notes all week, so I won't plan a virtual meeting unless you guys tell me that you want one, okay? And then I think the quiz is going to be on the 18th, and then the test is on the 19th. So that's that finals week, what would have been our finals week. And then those last 3 days are just going to be work days for you to finish stuff up and get stuff turned in, okay? The chapter 14 extra practice worksheet, that is in Canvas. So if you want to do that and take pictures of it and email it to me for extra credit, you can do that, okay? Do that for the chapter 12 one too if you want some extra credit in the homework category. Okay? Okay. All right, well, keep working hard. If you guys are showing up, that means you care, you're working hard. That's good to see, okay? Maybe other people at work, doesn't mean they don't care, but they're still working hard. They're just at work right now. They'll watch the video later, right? Okay, all right. Well, let me know if you have questions, okay? Email me, or if you have a Zoom meeting and you want me to hop into your Zoom meeting, send me the link, okay? I can pop in and pop out if need be, okay? Okay, all right. Well, take care, guys, and we'll see you later.